Hey guys, so here's our lesson for today. We're going to go ahead and go on over it. We're doing this a little bit different. We're doing a paper version of this instead of the tablet. Was having issues getting it to work on the tablet, so we just went ahead and did this. Let me know which version you like better now that you've seen two video versions. But it's the same lesson. We're still going to go over it, all the same stuff, just slightly different. So here's our do now. So the way I will do this, particularly for A Day, since I'm not there, you can go ahead, if you answer the do now and send me a picture of your work that is correct for the do now, I'll go ahead and give you 1 Z-Buck credited to your grade. So if you send me a picture of it, you can send it via Remind, I'll get you a Z-Buck for doing that. Okay? Otherwise, work on the do now, see if you can get it right. It's just a good knowledge check. Today's lesson, we're going to go over factoring, particularly factoring trinomials when a is equal to 1, and graphing quadratics or quadratic equations. Incoming, we have homework 2.4 due next class. Our Alex growth will be due by Sunday. I think I'm just going to permanently keep the deadline on Sunday. It seems to be better for you guys. It's no hassle on me, so I don't mind. Quiz 2.1, that already passed. You're going to be getting the grades back for that. That's something I forgot to take out from the last lesson. So, yep, without further ado, let's go ahead and get on into the lesson. So, just a quick review, right? Maybe you internally know this, but you don't explicitly know it. Factoring is just the process of breaking up numbers into smaller multiplying parts, right? So if you think of the number 6 and you can break that into 2 and 3, you just factored the number 6, right? It's about breaking a number into smaller multiplying parts. And that's what we're going to do, except now we're going to do it on a slightly more complex scale. We're going to do this to a trinomial. Okay, so you see that word trinomial, go ahead and start breaking that down in your head. What does trinomial mean? Well, we see the word tri, right? Triceratops, triangle, tri means 3, and nomial, right, still means term, just like a binomial, except this is a trinomial, which we see 3 terms right there, right? So that makes sense. We're going to factor things that have this format, right, that have a 3-term format, particularly where we have an x squared, an x, and no x term. Okay, now before we start doing this, a little bit of background knowledge that we need is that we're going to label the coefficients on these trinomials. And why are we going to do this? Because there's a very special relationship between these numbers, and we're going to be working with these numbers in order to factor this down into simpler parts. So we're going to need to identify parts A, or coefficient A, coefficient B, and coefficient C. Once you can identify those, we can then get into the factoring method. So let's go ahead and just do some quick practice on identifying A, B, and C. Okay, so we have a trinomial right here. We want to find A, B, and C for the coefficients. So if you remember, our format is ax squared plus bx plus c. Okay, now how we logically deduce this, we just see that the 2 is next to the x squared, well, so then therefore a must be 2, right? B is next to the x, negative 7 is next to the x. Notice no negative sign there, so the negative has to be included with the b. So b equals negative 7, and likewise c is equal to 6, right? They match up. They simply have to exist in order for this format to work. Okay, so those are our 3 coefficients, and once we find those, we'd be ready to do our factoring method later on in the lesson. One small thing, so this format, we actually do call this standard form. We haven't really worked with equations like this too much just yet, but I guarantee you we will see them like this. It's something that we're going to have to deal with, particularly when they don't come in vertex form. So this is one of our other forms. It's called standard form. And you're going to get used to it as we work more and more with it throughout the year. Okay, so same deal with this one. We're going to go ahead and identify A, and we're going to identify B, and we're going to identify C. Okay, if that helps you out, go ahead, write ax squared bx squared plus c at the top of each one, so it makes it a little bit easier for you to match it up. Also, writing this down, it's going to help you remember these things a lot better. You're going to remember the standard format just off the top of your head. So don't overthink this one. I know that we don't see an a there. Well, what number could it be? Remember, 1 can be that invisible multiplier. It can be the multiplier that's there without showing it, so therefore a is going to be equal to 1. B, pretty self-evident, right? B is equal to 7, and C is equal to 6. Okay, just like that, nothing complicated going on. One small thing, the biggest misconception I see is a lot of kids like to write ax squared for, or sorry, 1x squared for a. Notice you do not include the x squared in your coefficients. We're talking just about the multipliers in front of the variable, and the x is not included in that, right? There's a reason why we separate those two. It's because we're talking about the number, not the variable. Okay, so this is just 7, not 7x. A lot of people like to do that. All right, same dealio with this. So, I'm still going to write this up here, and you should too until you have this internalized. We're going to go ahead and start identifying. Again, we don't see a number there, but we can think of that as being a -1. So a would be equal to -1, b would be equal to 4, and c would be equal to -21. Okay. And side note, there's a very good chance that you guys are very familiar with this kind of stuff. If you are, that's awesome. I'm always going to work with you guys from the ground up to make sure you're good. If this is new and it's challenging, just keep working at it. I promise you will get it. If you're on the other side and this is just very easy for you, maybe skip past this, maybe do the exercises, but go on to the other parts of the video. Okay, so just like that, A, B, and C. We'll go ahead, we'll do one more, a little bit trickier, but not too bad, right? We're still going to do the ax squared, the bx, and the c. Okay, so we can go ahead and match them up. Notice a is going to be equal to pi, and I know you don't see a lot of math questions like that, and honestly, I think that's more a problem with our math system than it is problems like these. These are very good conceptual problems for you to do. But remember, pi is a number. It can be equal to things. It's just a Greek letter representing a number. So just like that, that's what a would be equal to. B, we see it lines up with 3 squared. We see that 3 squared isn't calculated, so we'll go ahead, we'll calculate 3 squared. That's just equal to 9. And then C is just going to be -47. Okay, now, again, one small side note. So notice these are being added, and our variables are defined based on our coefficients are defined based on the variables they are next to. So when we see that A, we know it's A because it's next to an x squared. When we see that B, we know it's B because it's next to an x. So it doesn't matter how I arrange these, meaning if I have C first, if I have bx first, it's always going to be based like this. We're always going to look to x squared to find A, always going to look to x to find B, and our constant to find C. So we can rearrange this just like we can do with addition, and it's not going to change A, B, and C. Alright, time to start doing our methods. So we know A, B, and C, which is good, right? Because you already see we're going to need to know those in order to do this method. Now here's the process for factoring, and I'm going to, I should have specified, this is factoring trinomials, right? Factoring trinomials. There's many different kinds of factoring that you can do. We're going to see many different kinds of factoring throughout the year. We're even going to see 2 different kinds of factoring within this lesson. This in particular is factoring a trinomial, and we actually call this method factor by grouping, but the name isn't as important as what we're actually doing. So learn the process, and then we can slap a name onto it, but if you're looking to research this more, it is called factor by grouping. Okay, so factor by grouping for trinomials. How does it go? Well, step 1 is going to be first find all the factors of A times C. So we know what A is, right? A is going to be this number in front, the coefficient right there. C is going to be the coefficient right there. So A times C would be 1 times 6, which is just 6. Okay, so good. Find all the factors of A times C. We see A times C equals 6, and we list all those factors. So 1 and 6, 2 and 3, and we got all the factors. right? Not a lot of factors for that one. Now we want to go ahead and find the two factors whose sum is b. Right, so find the two factors whose sum is b. So what that means, that is our second step, we want to find the factors that we just listed, right? Find the pair of factors that's going to add up to b. What is b again? It's going to be 7. Now, I like to format my problems like this, where I have a times c on top and b on bottom. It's easier to make the connection, it's nice and organized, and it makes our job simpler to do. So again, a times c equals 6. Here's the factors. Which of these factors adds up to 7, right? What would that be? Well, not 2 plus 3, but 1 plus 6. So that means that 1 plus 6, those are going to be our two magic numbers, our two magic factors that are going to make this process work. So we're going to go ahead, we're going to circle those numbers, and now, because we see that a is equal to 1, we can take a shortcut. And this is really important, right? Because believe it or not, there's a lot of math that goes on here, and a lot of math that's very hard to explain. But it's working behind here, and when a is equal to 1, we can take just this kind of arbitrary shortcut of just writing our numbers right there. Notice, right, you see the 6 and the 1 right there? And I literally, right, I found them, and I wrote them right there. That's our shortcut, right? When you find those two numbers, you can just put them in only when a is equal to 1. That's our shortcut, and it's a very nice shortcut, but there's a lot of concept that it's missing out on. So it's okay to take shortcuts, right? It's good, especially when you're being timed. But you do want to know it exists, and know that we are taking a shortcut, and eventually that shortcut will not be available to us when a is not equal to 1. Alright, so we go ahead, we found those two factors, and now we write the two factored parts after our shortcut using the two found factors. So we found those two factors, and we made our two factors, and boom. Just like that, we factored the trinomial. If you don't believe me, go ahead and show it. Right, we're going to do a little bit of polynomial multiplication to show that this works. What method should you use for this? I don't need to answer that, you already know. We're going to have x squared times 1, or x squared, and x times 1 is x times 6 is 6x, and 6 times 1 is 6. Right, so then I go ahead, I notice that these two terms are similar, so I'll go ahead and just add them all in one line. So x squared plus 6x and x is 7x plus 6. Boom. And just like that, right, it works. This stuff works, and it's, you know, I feel like for a lot of you guys, it's going to feel like black magic. It works. Why does it work? We're not entirely too sure, but it works like a charm. And somehow when you do this math, it just spits out the right factors, you know, that works every time. So it's really beautiful. It's cool how this is happening. And if you want to find out more about it, I can talk to you more about why this relationship exists. Okay, but you know, again, right, like I always tell you, you know, two kinds of understanding, mechanical understanding and conceptual understanding. You know, this is the mechanical understanding, and truth be told, you don't need the conceptual understanding. Is it good? Absolutely. Do I want you to get it? Absolutely. But if you can't get it, does it mean you're done? You know, you can't keep on going? Absolutely not. I mean, we're doing it right now. You don't understand what's going on, but you can do it, right? So, all right, let's go ahead. Let's keep on going on. The biggest thing to take away from this is a times c adding to b. That's going to be the thing you want to stick in your memory, because we're going to be using that all throughout these next problems, right? That's the key, finding a times c that adds to b. Factors of a times c that add to b. Say it after me if you need to. That's going to get drilled in your brain. That's what you need to know for this method. So, let's go ahead. I'm going to list a, b, and c on the side. Okay, if you need to write ax squared bx plus c up top to help you out with that, go ahead and do so. But a is going to be equal to 1, b is going to be equal to 2, and c is going to be equal to negative 3. Note, this is what fluency would look like, right? When you're doing this fluently, you can just list them out without having to have your format up there. Alright, so we have a, b, and c. Now remember, factoring trinomials, we are looking for a times c, right? Factors of a times c, so a times c is just going to be negative 3, that add to b. What is b equal to? It is equal to 2. So a times c that adds to b. Factors of a times c that add to b. Well, negative 3 is a prime number. Well, technically 3 is a prime number, but negative 3, right, also kind of prime. So we're going to go ahead and break it up into the only two numbers it can be broken up into, right? Negative 3, or negative 1 and 3. And we're going to break it up into that, and we're going to see if it equals 2. So negative 1 plus 3 is equal to 2. Well, that's good, right? That works. So we found our two numbers, and now we're going to go ahead and write x minus 1 and x plus 3. It breaks up just like that. And those are our two factors. It's, you know, it's really incredible. It's really incredible how this works, you know. Here's the proof for it. All right, we have x minus 1. We have, x plus 3. That would be x squared, negative x, and 3x, and negative 3. We go ahead, add these up, and we see it's x squared plus 2x minus 3, right? Bada boom, bada bing. It works. It's incredible. It really is incredible. I know I've said that a lot, but you know, it's really, you know, just think about this, right? Somehow, some picking of numbers, multiplying them and adding them somehow gets you a factored form, right? It's very, very spectacular. And just take a second to imagine what it would be like to be the mathematician to find this. It'd be very incredible. So, anyways, that is that. There was one more thing I was going to say. Notice, so here we actually could have two more factors, and you will get used to this as you do these. We could have had 1 and negative 3. There's a way to play with the negatives and to swap where you have your negatives to see if you can get that sum. And sometimes we'll have to do that. Sometimes we'll kind of strike gold and get lucky on the first try and get our two factors. Okay, so boom, right there. And of course, here's our answer. I know I showed that extra work, but that's actually our final answer. All right, let's go ahead and do another one. So A, B, and C. Right, and if you need to, pause the video, challenge yourself, see if you can find out what A, B, and C are. So we found A, B, and C. We're now going to remember the process is factors of A times C. So 1 times negative 18 is negative 18. And I want to find all those factors of negative 18, and then I want to pick out the two that add up to B, right? That add up to 7. So I'm going to start listing these factors. I have 1 and negative 18. That could work. I also have negative 1 and 18. That could work. And I also have 2 and negative 9. That could work. And I also have, negative 2 and positive 9. That could work. Okay, now as I write this and as you get better at this, I recommend checking your possibilities as you go through them. It's going to save you time, it's going to make you quicker, and you're going to start finding yourself brainstorming faster to get to these magical numbers, to get to these numbers that are going to make it work. So we're going to check them out. 1 plus negative 18, well, that doesn't add to 7. Negative 1, positive 18, well, that's no better. 2 and negative 9, we're very close. 2 and negative 9 would add to negative 7. So we're very close. And when you notice things like this, notice we're going to change the sign around a little bit to make it negative 2 plus 9. And now that'll equal 7. Right? So when you get the right number but the sign isn't right, just see if you can mess with the signs a little bit to get that to work. So we have negative 2 and 9. So that means, right, because of our shortcut, because A is equal to 1, we take the shortcut. And R minus 2 times R plus 9, that's our answer. Right? That is the factored form. Just like that. You got it. Okay? If you want to prove this works, go ahead and, if you're going to prove it works, that's great. Just do yourself a favor. Don't use FOIL method. Be kind to yourself. Treat yourself. Use the box method. You got a lot of space on the paper. No reason not to. We go ahead and we prove that it works. And right there. We'll go ahead and add them up. And you can see that that math works out. everything is good. This method that we're doing somehow magically works. Okay, so alright, let's keep on going. Okay, same deal. So now we encounter this problem, right? And maybe you pause for a second, right? Because we've been taking the shortcut. Remember, the shortcut relied on a equaling 1. And now you see that a would technically be equal to 4 right here, right? Right, you see that? You see a would be 4, b would be negative 8, and c would be negative 32. And you're like, what? Like, you know, like, what's going on here? Maybe you know the trick already, right? Maybe I'm holding you back for no good reason. But there's a trick that we can do to actually make this work. And there's a trick that we can do to bring this back for a equaling 1. Now, what is the trick? We go ahead and we're going to factor out this first term. Okay, factoring out that first term, that means we divide everything by that, and then we write it on the outside. Okay, so I'm going to factor out a 4 from here, which means everything else has to give up a 4 in terms of multiplication. So this is going to be x squared minus 2x minus 8. Now, how does that work? If you notice 4 times x squared, well, that brings me back to 4x squared. 4 times negative 2x brings me back to negative 8x. And 4 times negative 8 brings me back to negative 32. So we can distribute this to get back to where we came from. And that's actually sometimes a great way to think of this is what we did is reverse distribution. We pulled out a multiple of every term, which that's exactly how I knew how to do this. Was when I saw this 4 here, I immediately checked if the negative 8 and the negative 32 could be divided by 4. And lo and behold, it turns out they could be. And so then I divided everything by 4, and that's how I was able to factor out my 4. Okay, so now that we factor out the 4, this is a lot easier, right? We look at this, now we can look on the inside of here, and we see that we have on the inside of it, right? And I guess we can kind of do this problem to the side for right now, because we're going to come back to it. We're going to come back to this thing after we factor out the middle part. Right, so that's what a, b, and c would be for this. X squared minus 2x minus 8. And we can now do that factoring method. So again, a times c is going to be equal to negative 8. And we want to add to b with our factors, so that would be negative 2. And how do we add to that? Well, we want to list all the factors of negative 8. So we have negative 4 times 2. And just like that, right? Notice those are the first two I put down. It actually turns out that they work. Negative 4 plus 2 does equal negative 2. So we can go ahead and factor this into x minus 4 and x plus 2. Just like that. Okay? We see that this thing was factored into there, so we can go back into here and we can replace that with this. So x minus 4 and x plus 2. Just like that, right? We saw that that equaled that, so we just replaced it over here. This is almost like our side work. And if you notice, kind of like I mentioned earlier, this is our two levels of factoring, right? First, we had to factor out what's called a greatest common factor. They all had a greatest common factor of 4. So I went ahead and factored that out. And that then broke this problem down to something a lot easier, in which we could do our factor by grouping method by factoring a trinomial. Okay, so sorry, just getting a little sip of water. A lot of talking going on. But that would be it. Again, you could go ahead, do your polynomial multiplication to prove that works. I'm going to leave that to you at this point, just so we can keep on rolling. But you can multiply that to see that it works. Just don't do FOIL method if you're going to do that. It would be kind of, how do you say, embarrassing. Alright, so again, one more problem, and you're going to get to this one, and maybe you get thrown off a little bit because you see r cubed, right? You come over here, you start trying to set up a, b, and c, and if you remember correctly, we're going to look for something squared. We're going to look for something not squared, and then we're going to look for just a constant, not with a variable. So everything is kind of shifted here, right? Or in particular, this is a degree higher, this is a degree higher, and this has, a variable when it's not supposed to have a variable. So what's the deal? What gives? How do we go about solving this? Well, it's actually going to be very similar to this previous method where we factored something out. Except this time, the thing we factor out is going to be a variable. Notice, if we factor out an r from here, and before I factor that out, can I factor out an r? Well, yes, they all have factors of r. Notice they all have r's in them. So I'm going to go ahead and factor out an r. So I write my r on the outside. Now what do I write on the inside? I write what would multiply to the thing above it. So r times what equals r cubed? Well, that would just be r squared. R times what would equal negative 7r squared? Well, r times negative 7r would equal negative 7r squared. And r times what would equal negative 18r? Well, negative 18 times r would equal negative 8r. Notice it's just reverse distribution. We are now going backwards with our distribution for the sake of finding these factors. And if you're wondering why we're doing all this nonsense, you're going to see why. There's very good reason for it, I promise. So we factor this backwards, and then lo and behold, right, we are now back to the stuff that we know, the stuff that we can do. Right? We can now see that a is equal to 1, b is equal to negative 7, and c is equal to negative 18. We can now go ahead and we will find our factors of a times c that add to b. Okay, b is equal to negative 7, a times c is going to be negative 18, and I feel like we did this one before. Did we do this one? I feel like we did. Who knows? They start to blend together at certain points. So what multiplies to negative 18 but adds to negative 7? Well, negative 9 and positive 2, right? And you kind of, and you're going to get good at this. You're going to get to the point where you can kind of just like pick out your factors on the first go. So negative 9 and times 2, does that equal negative 18? Absolutely. And negative 9 plus 2, does that equal negative 7? Absolutely. So these are the perfect numbers. Those are the golden factors. We're going to use those. And now we're going to take our shortcut, because a is equal to 1, and we're going to write r times r minus 9 multiplied by r plus 2. And just like that, we factored our problem. Look how neat this looks. When you really streamline this process and you really master it, your problems are going to start looking like this. Okay, so just like that, we have got our factoring down. Notice occasionally, sometimes we have to factor something out. Sometimes we have to factor out a greatest common factor before we do our method. But once we do so, we're just going to find a times c adding to b and find those two special factors. And for right now, while a is equal to 1, we can always take that shortcut. It's going to make our life very easy. You're going to see when we do not have the shortcut, you're going to wish we had the shortcut. So it's good math problems, really good math problems to do, but you're going to wish we had the shortcut. Okay. My apologies. When I put this problem in there, I thought we could have factored out that 3. But after I look at it more closely, we actually can't do that. So this is a problem that we're going to save for later. But as you see, right, factoring polynomials is totally an ACT question. You're going to see this if you haven't already seen it. So why learn this method? Because it will directly translate into points on your ACT. Right? If you want to grow a couple points, learn factoring. Just that simple. But we will come back to this later once we have more advanced methods with no shortcuts. Shortcuts are bad. Don't take shortcuts. Only when you know about them, then you can go ahead and take it. Okay, cool. So now this part is easy. It's easy. You're gonna see why it's easy, right? We have to solve the quadratic equation, and maybe you look at this and it like kind of intimidates you. But let's put some conceptual framework around this to make you be like, oh wow, that's actually really easy. So think about it like this: we have two parentheses, right? And they're both multiplying to what number? So the question you got to ask yourself, what number or what two numbers could multiply to 0? Right? What two numbers could multiply to 0? Well, 0 and 7 could multiply to 0. 0 and 2 could multiply to 0. 0 and 5 could multiply to 0. And actually, now that I think about it, any number times what could multiply to 0? Yeah, that's right, right? Any number times 0 could multiply to 0. So what does that mean? Why is that a brilliant thought? Because what if we get one of these to equal 0? For instance, what if I said n equals -3? Right? Well, -3 plus +3 would be 0. Right? And we'll go ahead, we'll test it out over here. So if we had -3 plus 2, n plus 3 is equal to 0. So, oh, I'm sorry, that's supposed to be a -3. So if we did that, well then we would get a 0 right here times -1. -1 times 0 is equal to 0. That's a solution, right? N equals -3 just worked for this. So one of my solutions is n equals -3. How did that work? Well, because I made one of my terms equal to 0. Right? And now if you're thinking mathematically, if you're really trying to investigate all the possibilities, what else could you do? Right? What else could you set n equal to that would make something equal to 0? Right? You guessed it. N equals -2. And you're going to notice, right, the same kind of pattern goes on here. We can go ahead and we can check it. And we're going to see that it didn't make a difference, right? We had a 0. And then remember, anything times 0. It's going to equal 0. Now, this is powerful stuff. This is very powerful stuff, right? If we get two factors set equal to 0, doesn't matter what the other one is. We for all intents and purposes, cover one of them up, find what makes that equal to 0. Likewise, cover the other one up, find what makes that equal to 0. Right? That found us two solutions. We found two solutions. Now, I'll give you a small tip, right? Why should we expect two solutions? Well, because we have two n's in here, right? We have n times n, and if we were to multiply that out, that would give us n squared. And there's actually a rule in algebra: for every power of your variable, you should expect at least that many solutions. So if we have x cubed, we should expect three or less solutions. It can be less, but it can be up to 3. So, anyways, yeah, so, right, all we had to do was set either one of these equal to 0, because if we did that, it made everything go to 0, right? 0 times anything will go to 0. Therefore, we can get just one of these equal to 0. Okay, that's the first way to think about these. Now, if you're a little bit more analytical like me, and you want a analytical method to show how this works, well, here's what you can do. You can think of this as two scenarios, right? N plus 2 and n plus 3. And again, we're very curious mathematicians, and we try stuff out, maybe not knowing if it's going to work. Something we're going to try out is dividing both sides by n plus 3. Weird, right? Who would have thought to do that? Well, let's go ahead, let's check out the consequences of it. N plus 3 divided by n plus 3, they cancel, right? Those are the same thing, right? Don't get me wrong, those are the same thing. So they can cancel, right? So they cancel. Now I have 0 divided by n plus 3. Well, this looks like it doesn't help. I don't even know what the heck n is. But then wait a second. 0 divided by something. 0 divided by anything, what's that equal to? It's just like 0 times anything. 0 divided by anything, that's still equal to 0. And what am I left with on the left side? Well, just n plus 2. You see what's happening? Do you see the magic unfolding right before your very eyes? We go ahead, we use our algebra skills to solve that. And just like that, it works, right? No matter how you want to think of it, whether you think of it, bottom up or top down, it's going to work. Right, let's go ahead and let's try this trick. Let's do it the other way just so you can see it, just so you can practice it. N plus 2 times n plus 3. We got that equal to 0. We're going to go ahead. So we got rid of the n plus 3 the first time. Let's go ahead and get rid of the n plus 2. How do we do that? Well, we divide by n plus 2 on both sides. That was our trick, right? we saw that if we divided by it, we could cancel them out. And now 0 divided by n plus 2 is equal to 0. And we have n plus 3 left over on the left side. Bada boom, bada bing. I think I say that because I'm Italian. N is equal to -3. Just like that. So notice, two ways of thinking of this. One maybe a little bit more direct. One maybe a little bit more analytical and robust for tougher problems. Both of which find us solutions for when things are multiplying to 0. Right? And that's really the key to this. That's what you really want to wrap your mind around, is that things are being multiplied to 0, therefore just one of them has to be equal to 0. Right? When you multiply to 0, only one has to be equal to 0, and it will bring everything down to 0. Okay? Alright, let's go a little bit quicker on this one, because now we know the trick, right? We just need to get one of these things to equal 0. So, okay, well, this is easy, right? I just look at this. What's going to make this one equal to 0? Well, that's just 7, right? Because 7 minus 7, that goes to 0. So that's solution 1. And then what's solution 2? Well, what's going to make that go to 0? Just 1. Just like that. Okay? And I'm going to show you guys again that analytical method for doing it. Right? We have x minus 7. We have x minus 1. And, you know, for some of you guys who really need to see the proof, this is kind of like where you can see it coming from. Right? When you divide by something on both sides, you see how the trick plays out. Those two cancel. 0 divided by x minus 1. You get x minus 7 left over on the left side. 0 divided by anything, that is 0. And then you add 7 to both sides and you get x equals 7. Confirms what we guessed. Not guessed, but reasonably figured out. So x minus 7, and we're now just doing the second version of it. And, you know, it might be redundant at this point, but, you know, it makes very good practice. So x minus 7 divided by x minus 7, those two will cancel. 0 divided by anything is 0. X minus 1, a little bit of algebra shows us that x is equal to 1. Okay? Just like that. It's incredible. It's very beautiful. And now, right, maybe you're a smart person. You know where this is going. You know what the next problem is going to be. Oh, right? So what's happening? Notice, right? That factoring method, right? This whole time we were working with things that were pre-factored. Now we gotta factor them. We're gonna factor them. Why? Because it's set equal to 0, and that's gonna allow us to then find out our solutions very quickly. Right? And this is very powerful. Take a second, realize this. We have x squared, right? We have a quadratic written out like this. Not written nicely, not a vertex form, nothing nice like that. But as long as it's set equal to 0, we can factor it and find out what the solution is. Very powerful stuff, very powerful. You're going to need to remember this all throughout the course. Right? Quadratics, we factor them when they're set equal to 0. So we want to get them set equal to 0, factor them, and then we can easily find our answers. Okay, so this one's set equal to 0. We just got to factor this side. So remember, I'm looking at ax squared plus bx plus c. That means a is equal to 1, b is equal to 5, c is going to be equal to 6. And I'm going to go ahead and find the factors of a times c that add to b. That's the trick, right? I'm just doing my trick. A times c adding to b. So a times c is going to be 6, b is going to be 5, and maybe the numbers already hit you, right? What could multiply to 6 and add to 5? Well, 2 times 3. Right? Just that simple. And notice a is equal to 1. We can take that shortcut, and we can write a plus 2 and a. Oh, sorry, that's my bad. Right, x. X is the variable we're working with, not a. That's my apologies. X plus 3. You guys thought you were going to get Z-Bucks, didn't you? Not today. Not today. Alright, so x plus 2 times x plus 3. And beautiful, right? Just like we did before. Just like on these problems, we can now easily identify what our solutions are going to be. Right? So what are our solutions going to be? X equals -2 for this one, and x equals -3. Just like that. We got them. Just like that, we got them. We're now putting it all together, right? You see it now. You see what's happening. We got factors and multiply to 0. We factored it to get the factors, and now it's just easy to find what would balance out those factors. Okay, really good stuff. We are approaching the climax of the lesson, the peak of it, the vertex of it, depending on which way we're going. Sorry, that's really bad. But so you're now really gonna see it come to life, right? Because now we're to the point where we're graphing quadratics in factored form. So the idea behind this is that we are going to, give me one sec. We're gonna use this to make a graph, right? Now, why is, how can we do that? So here's the thing, right? When we were finding the vertex, what format was it in? Right, it wasn't in this format. It didn't look like this. It was actually in what we call vertex form. And why do we call it that? Well, because it's easy just to read off the vertex, right? Before we had something where it was like something inside, something outside, and inside was opposite, left and right, outside was the same up and down, and that was our vertex, right? We could just read it. But not anymore, right? We have something that's being added to x, something being subtracted. What the format doesn't work, we can't resort to that. So we have to find another way of finding the vertex. How do we do that? Well, we're actually not going to start with the vertex, and we're actually going to first start by finding the x-intercepts. Okay, finding the x-intercepts, right? Finding the x-intercepts, you're going to see it. Maybe you already know why we worked on the other stuff, right? How does this relate to the stuff before? Well, remember, because when you're trying to find the x-intercept, right, x-intercept, what are you going to do to y? You're going to turn it off, right? You're going to set equal to 0. And right now, right, light bulbs should just be going off in your head. What's going on? What are we going to do? Right, what are those x-intercepts? Well, that's easy, right? That's x equals -3. And that's x equals 1. That's easy, right? Like, look at that. It's right there. So, -3, 0. That's our first intercept. And then we got 1, 0 for our other intercept. Just like that. Right? Like, look at that. Wasn't that easy? That was super easy. So now we'll go ahead, we'll go over onto our graph. We'll, start plotting our points. We're still talking about a graph after all. There's our x-intercepts. We also got to find our y-intercepts, so I guess let's go ahead and do that next. Remember, x equals 0 for the y-intercepts. So then y would be equal to 0 plus 3 times 0 minus 1. 0 minus 1, we're going to see that that's equal to a negative. So that would be 3 times -1 would be -3 is our y-intercept. So 0, -3 would be our y-intercept. You notice this is going kind of quickly, right? It's not too hard so far. Right? I just knocked out my x and y intercepts really quickly. And again, that was all thanks to that vertex form. Now, I'm not going to connect these two dots because the thing is, I have not found the vertex. It would be mistaken of me to connect it like that, because that would imply this is the vertex, and I don't know where the vertex is. But what we're going to do is we're now going to use our x-intercepts to find our vertex. Well, how do we do that? And I want you to think critically about this, right? Where would a vertex be with respect to these two x-coordinates? And better yet, imagine a parabola between these, right? Imagine a parabola, it's got to go downwards. Where would the vertex lie? Right, somewhere in your head, you're kind of thinking of it like this. Right, if you got a really good mental image of what a parabola looks like, you imagine it like this. How do you imagine it like this, right? Well, it's because of a beautiful thing called symmetry. There's symmetry in a parabola, right? This thing's got to be split perfectly on the left and on the right. Well, what does that mean about the coordinate of the parabola? Well, that means your coordinate has to be smack dab in the middle of, you guessed it, your x-intercepts. right? Just like that, your vertex is going to be right in the middle of your x-intercept. So how do we find our vertex? Well, we're going to start off by finding the x-coordinate of it. It's right in between our two x-intercepts. So we're going to go ahead, and so for the vertex, we're going to find the average of our x-intercepts, right? The average of them would be right in the middle, be finding the midpoint of it. So remember, how do we find the average? We add the two numbers up, and we divide by 2. So negative 1 plus 3 divided by 2 is equal to 1. Oh, and I'm sorry. That's my mistake. It's a negative 3 and a positive 1. So 1 minus 3 is equal to a negative 2 divided by 2 is equal to a negative 1. There we go. That's much better. And notice I'm able to catch a mistake like that because of my graph thing. Your graph is able to help kind of point you in the right direction. So the x value for our vertex is equal to negative 1. Right, I plug in negative 1 to this thing, and then I see that's right in between my x-intercepts, and that's how I know it's my vertex. Okay, again, and I just want to say that one more time, maybe you guys are missing that. It's right in between where our two x-intercepts are. This thing is symmetrical, therefore it's always going to be halfway between our two x-intercepts. So I found the average distance between our two x-intercepts, and that gave me the point at which I would have my the x value for my vertex. Okay, so I found the x value for my vertex. Now, is that the whole vertex, right? Is that the x and the y for the vertex? No, right? It's just the x. We now have the job of then using that x to go in and finding y. And that's what we're actually going to do right now, because we have the y value for our vertex, or sorry, the x value, we just don't have the y. So we're going to go ahead, plug in negative 1 to our equation, and calculate that out and see what it equals, so that way we can find also the y value for the vertex and have the entire coordinate of the vertex. So negative 1 plus 3 is negative 2. Negative 1 times negative 1 is negative 2. So positive 2 times negative 2 is going to be negative 4. Okay, if those calculations are hard for you, again, show them on the side. Take a little bit more time to do that work. It will come to you that way. So I plug in negative 1, I get negative 4 as my vertex. And notice I go back 1 and down 4, and right, it's a pretty good, darn good estimate that makes sense, and you can see a nice, beautiful, symmetric parabola going like this. Just like that, we were able to use some of this symmetry along with the x-intercepts to find out how our parabola is going to look. Okay? So kind of cool, right? Kind of cool. At least, I think so. It's very clever, where instead of going straight for the vertex, now we're finding the x-intercept, because that's going to allow us to get to the vertex. Okay, so same deal over here, right? The vertex, going straight for that would be more difficult. So we're going to find a way around it. We're first going to find our x-intercepts, and then we can remember that, right, just like before, smack dab in the middle of our x-intercepts was our vertex. So let's go ahead. We're going to find our x-intercepts, and, so x-intercept, y is equal to 0. And, these are easy, right? We know what the trick is to them. So our x-intercepts at this point are just going to be x equals 2 and x equals negative 4. So we'll write negative 4 comma 0. And we will write 2 comma 0 for our x-intercept. Okay, remember those are the things that set it equal to 0, brings everything to 0, therefore those are our two x-intercepts. We'll go ahead and sketch this out, going over 4. 1, 2, 3, 4, just like that. And then going over 2, just like that. Okay, found my x-intercepts. Let's go ahead and find our y-intercept. It's not hard to find, so let's do that. Remember, we plug in 0 for this. So our y-intercept, and I'm showing a little work for this because, it is definitely some computation, and I don't want to get it wrong. So 0 minus 2. We go ahead and we multiply these. Negative 2 times 4 would be negative 8. Negative times a negative is a positive. 8 divided by 2 is equal to positive 4. So we should see our y-intercept somewhere at 1, 2, 3, and 4 right there. Just like that. And honestly, when you look at this, right, something tells me our vertex is going to be somewhere around there. Because we can see this thing kind of curving like this. And if we know it's symmetrical, we're going to imagine it to come something kind of like this. Somewhere around there. That's where my prediction is. We'll see how good that prediction actually is. Alright, so yeah, now let's go ahead and let's find our vertex. So remember, we know the vertex has to lie smack dab in the middle of our two x-intercepts. So we're going to find the average of our x-intercepts. That's going to find the midpoint. And so the average of -4 plus 2 divided by our 2 points is equal to -4 plus 2, which is -6. No, I'm sorry. That's a lie. That's a mistake. That's equal to -2 divided by 2, which is also equal to -1. So again, our x-intercept, or our vertex, is back 1, right? Halfway between, it's back 1. That even makes sense with our graph. So we'll plug in -1 for our vertex, and we'll find out what the y value is. Because remember, we just found the x value for that vertex. It could still be anywhere up and down on our y-axis. So, well, not y-axis, but, y direction. So we'll go ahead, that was for our x value. Now we'll go ahead and find y by plugging in -1. So -1 plus 4, and -1 minus 2. That is going to give me -1/2, and I will get -1 plus 4 will be 3, and then this will be -3, and so then that will be equal to a positive 9/2. Cool. So I see that what I get out is a fraction. It's 9/2. And I go ahead and look up here. 9/2 would be equal to 4/2. And I see that I actually went up 1, 2, 3, and 4. And just right there, just like that, it's a pretty accurate prediction. And again, this is why it matters, and this is why it's really good to draw some good looking graphs. Because then you can actually start predicting some of these values. Okay, so 9/2 was the y value, and that's our vertex and our intercepts, and that's our graph, right? Looking pretty good. So just to recap how we did that, we found our x-intercepts. That allowed us to find the midpoint for our vertex, and then the midpoint for our vertex, just the x value for the vertex, we then plug that in to find y. We now have our vertex, and the y-intercept, we just plugged in x equals 0. Okay, just for good measure, we're going to go ahead and do one more, and like you might have guessed, actually we got two more for very good measure. Right, and so now this is the grand finale. This is the conclusion. This is where we're putting all the skills we worked on together in this lesson into one thing. So we're going to go ahead, and we are first, right, so many different ways you can approach this. The way not to approach is by trying to find the vertex. Or at least you could, and you would look at this and, your vertex form reading isn't going to work on it. It just doesn't work anymore. So when you see this, when you see standard form, you're going to want to think about factoring. So we're going to have A equals 1, B is equal to 10, and C is equal to 24. Right, we go ahead, we do our little table stuff. A times C, which is equal to 24, adding to B, which is equal to 10. So A times C is 24. What are the factors of 24 that add to 10? Well, how about 4 and 6? And are those right? Well, 4 plus 6, yep. That works out really well. So we can now go ahead, and A is equal to 1, so we can take our shortcut. So we will have x plus 4, and we will have x plus 6. Right, that checks out. You can use polynomial multiplication, box or FOIL method. I know I just said it. I feel terrible. To go ahead and check that, but that's our factored form. And so from this, we're going to tell, right, if we found our x-intercepts by setting y equal to 0, that's going to mean that our x-intercepts would be equal to -6 and x equals -4. Right? How do we know that? Because both of them equal 0. So that's going to mean that's our x-intercept. Y was set equal to 0, and those would zero out both terms. So we have -4, 0. We have -6, 0. And those are our two x-intercepts. Now we can go find the vertex, right? Now we can find that vertex just like we did before. Remember, right? The vertex was smack dab in the middle of our two x-intercepts. So we're going to go ahead and we're going to find the average of our two x-intercepts. And I'm going to write x-AVG just to say the average of our x-intercepts. So we're going to have -4 plus -6 divided by 2. Well, that's going to be equal to -10 divided by 2, which is equal to -5. So the x value for our vertex is -5. And now what is the y value for it? Well, we're going to have to plug in -5 to figure that out. And notice there's one of two ways you can work with this. You can plug it into your expanded form like this. That'll give you one number. Or you can plug it into your factored form. That'll give you the same number. It's really up to you and how you want to plug this in. I'm going to plug it into the factored form. I'm going to do that because I notice -5 plus 4 is actually a pretty easy calculation. And the same with -5 plus 6. So I go ahead and I plug those in, and I'm going to see that that equals a +1 over here and a -1 over here. -1 times +1 is just equal to 1. So what's the y value for my vertex? It is 1 right there. Okay. Found that. I now need to go ahead and find my y-intercept. And remember, y-intercept, we're setting x equal to 0. And again, we do have the option of choosing either the standard form to plug it into or the factored form. I'm going to go ahead and choose the standard form because if you notice, plugging in 0 is going to get rid of that term. Plugging in 0 is going to get rid of that term. It's going to leave me with just 24. So that's a very easy calculation. We can go ahead and find it. Now we'll sketch this out. We go back 1, 2, 3, 4, 5, and back 6. Oh, darn, crap. Oh, that's the bad thing about this. You can't erase it. Alright, so we went back 5, but then we had to go up 1. So it's right up there. Oh, good lord, and I just realized I made another mistake. Man, I bet you guys were shouting Z-Buck at the camera. Forgot to carry the negative on that. Now, how did I catch that mistake? Because when I saw that my vertex was going to be above the x-axis, and my x-intercepts would be right there, that told me if it would have been like that, it would have gone downwards. And I can look at this and I don't see a negative there, and so I know this has got to open upwards. Just like that. Okay, and there's my parabola. Where's it going to intercept the y? Somewhere up there at 24, right? I'm just estimating at that point, but somewhere up there at 24, this thing is going to cross over. Bloop. Just like that. Okay? We did it, right? This is the grand finale, right? This is all our skills being put together. You know, this is beautiful. You should be proud of yourself. These are very highly developed math problems that you're doing. So let's go ahead. Let's do one more. It's going to be the same dealio. That's just a little bit higher on the difficulty scale. Why is it a little bit higher? Because notice, right, we're going to immediately think about factoring, right? We see something, we don't know where the vertex would be. It's written in standard form. We're going to think about factoring, but is a equal to 1? Well, no, it's not. It's equal to -5. So Can we factor out a negative 5 from this? Well, of course we can. All right, so we're going to factor out a negative 5, and we have a x squared, we have a plus x, and we have a minus 2. Right, does that work out? Well, negative 5 times x squared is negative 5x squared, negative 5 times x is negative 5x, and negative 5 times negative 2 is positive 10. Okay, so this does work out. I did do the reverse distribution correctly, and now we can go ahead and factor out that inside part. So I noticed that a is equal to 1, b is equal to 2, c is equal to 3, and what am I talking about? I'm sorry. I was saying one thing and thinking another thing. So you're going to reach a point like this where you're just going to stop writing A, B, and C because you're so easily to pick them out. It's so easy for you to pick them out. You're just going to do it and you're not going to write it out. Okay, so A times C, that's 1 times negative 2. So that would be negative 2. And then what is B? B is equal to 1. Notice, right? Be that coefficient of 1. So what two numbers multiply negative 2 but add to 1? Well, let's try negative 2 and positive 1. Does that work? Negative 2 times positive 1 multiplies negative 2. Negative 2 plus 1. Ooh, that equals a negative 1. So notice, right? I just need to get the sign switched on it. So I'll do a negative 1 and a positive 2. And now that fixes everything. Those are my two magic numbers. And I can write this as negative 5 times 2, or I'm sorry, x. We're just going to take a new line. This is what stinks when you can't erase. I like tablets better. 5, and we're going to write now x plus 2 times x minus 1. Using those special numbers, able to take the shortcut because a is equal to 1. Okay, so now this is the easy part, right? If we go ahead and set this equal to 0, we can now see that our x-intercepts are just going to be equal to negative 2, and then x can be equal to 1. So our intercepts would be negative 2, 0. Our intercept would be, our other intercept would be 1, 0. And we can now remember use these two intercepts to find our vertex. Why is that? Because the vertex is going to be smack dab in between our two intercepts, right? We can imagine there's going to be some parabola, maybe opening downwards, maybe opening upwards, right? Actually, and I see a negative on that, that tells me this thing has got to open downwards. So I'll go ahead, I'll find the average of that, right? Find the midpoint of it, and that would be negative 2 plus 1 divided by 2. And negative 2 plus 1, what would that equal? That would equal negative 1/2. And so negative 1/2 is my x value for my my vertex. Negative 1/2. What is the y value? Well, I have an x. I can go ahead and find my y. So I'm going to plug in y. And again, you have some options at this point. You can choose to plug it into the standard form or the factored form. I think factored might be a little bit easier, so I'm going to plug it into there. Negative 5 times negative 1/2 plus 2, and then negative 1/2 plus, oops, sorry, not plus, minus 1. Alright, I go ahead and calculate that. Doing some fraction math pretty quickly in my head, I'm going to see that this is equal to a negative 3 over 2. This is going to be equal to a positive 3 over 2 times the negative 5. Go ahead and multiply these out, and that's going to give me 3 times 3 is 9, times 5 would be 45. And negative times a negative makes it a positive. 45 divided by 2 times 2 would be 4. So that is the y value for my vertex, negative 1/2, 45 over 4. And negative 45 over 4, that's going to be up at least 10 units, so that's way too high for us to see. It's going to be somewhere up there, very stretched out. But we could kind of imagine what that's going to look like. And then we're going to go ahead and find our y-intercept, the very last intercept, right? Finding the vertex and the intercepts. Plugging in 0, and this time I'm going to use my standard form. It's just a little bit easier to calculate. 0 squared, that's just 0 times negative 5, gets rid of that term. Negative 5 times 0 gets rid of that term, plus 10. So I'm left with just 10. And just like that, that is my vertex, or that is my y-intercept. And those are, yep, that's it. So that would be up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It'd be somewhere up there, you know. This isn't drawn to scale, and this is why I harp so much on you guys about getting graph paper and drawing these things to scale, because it's really going to keep everything accurate, allow you to see what's going on. But yeah, I mean, the most important part here is the math. The most important part is our factoring method. The most important part is then setting it equal to 0, being able to do these easy calculations because of the things multiplying to 0, and then finding our x value for our vertex because we know it's directly halfway between our two intercepts. Okay, so alright, well I hope this helps. If you have any questions, of course, just go ahead and ask me. Yeah, and I look forward to seeing you guys soon.